In this lesson, we will look at the different types of actuators used in autopilots, why automatic synchronization is provided, the necessary interlocks that have to be made before the autopilot will engage, and the reasons an autopilot will disengage. We will then look at the autopilot function AutoTrim and a non-autopilot trim function MacTrim. Next, we will examine the autopilot interface. And finally, control wheel steering. We will start by looking at the autopilot's muscle, or how it moves the aeroplane's control surfaces. The autopilot achieves this by using either rotary or linear servomotors, of which there are two basic types. Servomotor actuators are either electrical or hydraulic, and can be connected in one of two ways with respect to the remainder of the flight controls. If the servomotor is connected in series, with the pilot's control and the control surface, then when the autopilot is engaged, the command from the autopilot servo will cause the control surface to move, but will not simultaneously move the control column. If the servomotor is connected in parallel with the pilot's controls and the control surface, then when the autopilot is engaged, the command from the autopilot servo will cause the control surface to move, and will simultaneously move the control column through the mechanical control linkage. This will enable the pilot to have some visual confirmation of the autopilot command. Most aircraft with traditional mechanical controls will have their pitch and roll channels connected in parallel, and their yaw channel connected in series. The yaw channel is likely to incorporate a yaw damper, which will continually counteract any Dutch roll tendency. This will be fully explained in another lesson. The series connection of the rudder will prevent continual small movements of the rudder pedals. Aircraft with fly-by-wire control systems have different arrangements, dependent upon the manufacturer. The autopilot cannot be engaged on the ground and used for the takeoff. The pilot will be ready to engage the autopilot at some point after the takeoff when the gear is retracted and the aircraft is in a steady climb. It may also be a standard operating procedure to fly the aircraft manually until the flaps are fully retracted. At this time, the pilot will have trimmed the controls to maintain the desired attitude without any continuous stick force. Within the flight control computer, there are synchronizing circuits which will continually synchronize the autopilot with the attitude and trim of the aircraft, so that at the point of autopilot engagement, the autopilot will take control of the aircraft smoothly, without jerking or the tendency for the control stick to be snatched from the pilot's hand. The autopilot will then maintain the attitude that existed at the time of engagement until further guidance commands are selected by the pilot. However, without synchronization, engaging the autopilot could jerk the control column, even wrenching it from the pilot's hands. Clearly, this is not an ideal situation, and serves to point out how important the automatic synchronization is. Before the autopilot can be engaged, a series of interlocks must be satisfied, and remain satisfied, to allow the engage interlock relay to hold the autopilot engage switch in the closed position. The first interlock consists of the autopilot disengage button, of which there are normally 3. There is one on each of the pilot's control columns, and one on the main control panel. The autopilot needs electrical power, and therefore has a power monitor interlock. The rate gyro that senses flight attitude disturbances must have a valid signal, and the autopilot computer and the servomotor must have successfully passed their self-tests. The autopilot also requires hydraulic pressure to be able to move the flying controls. Finally, the pilot needs to select the autopilot to engage. The autopilot will disengage if any of the previously mentioned interlocks open. In addition to the interlocks, attempting to select a second autopilot to engage will cause the first one to disengage, unless approach is selected. The autopilot will also disengage if the pitch auto trim system is either operated by the pilot or the system fails. This is covered later in this lesson. When an autopilot disengages, either by operation of one of the switches or for any fault, there will be visual and oral warnings. When the autopilot is engaged, it has to be capable of continually trimming the aircraft in pitch to account for variations of the centre of gravity, configuration and speed. If this did not happen out of trim, forces would be felt on the servo motor, and at the point of autopilot disengagement, a pitch input would occur, causing the control column to be snatched or jerked. To allow for this, an automatic trim or auto trim system is fitted to continually remove any out of trim forces in pitch when the autopilot is engaged. When the pilot is flying the aircraft with the autopilot disengaged, he will trim the aircraft manually. Fly-by-wire aircraft have a full-time auto-trim system that operates in autopilot and manual control. Most airliners have a trimmable horizontal stabilizer and elevator combination for pitch trim and control. If the auto-trim system fails, the autopilot will not remain engaged. It cannot be allowed to control the aircraft if it cannot trim in pitch. If the pilot operates the manual pitch trim when the autopilot is engaged, the autopilot will disengage. Aircraft that fly at high subsonic or transonic speeds may suffer from Mach tuck or tuck under. This is a nose-down pitching moment caused by the rearward movement of the centre of pressure at those speeds. A Mach trim system is provided to counteract Mach tuck. It is independent of the autopilot and is switched on for the whole flight, but will only have an input into the controls to counter Mach tuck when the aircraft encounters the onset of the necessary speed range. On the glare shield is the mode control panel, which allows selections for the autopilot, flight director, and auto throttle. The mode control panel is easily accessible to both pilots. To engage the autopilot, the engage button for the selected autopilot is pressed. If the interlocks are made, the autopilot will engage and a light in the button will illuminate to signify engagement. There will also be an indication on the flight mode annunciator. The flight mode annunciator, FMA, forms part of the primary flight display, PFD, along with displays of airspeed, attitude, altitude, vertical speed, and heading. The FMA usually occupies a strip across the top of the PFD, showing the AP engaged status, pitch and roll armed and engaged modes, and auto throttle engaged mode. Typically, engaged modes will be displayed in green, with armed modes in white. After the autopilot is engaged, the pilot can then select a pitch and roll guidance function as required. To disengage the autopilot, there is a disengage button on each control column and a disengage button on the mode control panel. When pressed, the control column buttons will disengage the autopilot and cause an aural and visual warning to occur. Which can be cancelled by pressing the button a second time. If the autopilot should disengage on its own, the same aural and visual warning will occur to alert the pilot. If the autopilot is engaged in control wheel steering mode, using the control wheel steering button on the MCP, then the pilot can use normal control forces on the control column to fly the aircraft with the autopilot engaged. The system achieves this by using a force transducer to convert a manual input to an electrical signal that the autopilot computer uses. The signal then goes through the autopilot's normal inner loop to move the control surface via the servo motor. Once the aeroplane achieves the new attitude, the pilot completes the feedback loop, releases the input, and the autopilot maintains this new stabilized attitude. During this lesson, you have learned how the autopilot moves the aircraft's control surfaces, the interlocks that have to be made before the autopilot will engage and remain engaged, and the reasons it will disconnect. Next, you are shown AutoTrim, which is an autopilot function, and MacTrim, which is not an autopilot function. And you studied the pilot-autopilot interface, the mode control panel. Finally, we considered the control wheel steering, which allows the pilot to use the control column to control the autopilot.